Good day, my dear 8th class students. Some time back I taught one chapter, that is chapter 9, area of plane figures. I am a little bit sorry that I did not continue and finish the chapter because I was occupied with some other lessons for 9th and 10th. I am sorry about that. I hope I will be able to pick up the speed and move on fast in the mathematics subject for you. Before I start it, there are already about 170 videos are recorded for different subjects, starting from UKG all the way to 9th standard. More than that, we already started June classes for 10th class and 9th class. I am very happy to say we are having almost 100% attendance in the 10th class and maybe about 75-80% in 9th class. Basically, the problem is because of the location, not having the proper cell. Hopefully, we will be able to solve that pretty soon. We are also thinking of starting the June classes for 7th and 8th. We are in the process of getting the telephone numbers to make sure 8th class students have the opportunity, have the ability to attend the June class. Okay, with that introduction, and one thing I want to remind you is that you all have to have the textbooks. Without the textbooks, it will be almost impossible, particularly in the subject of mathematics. You have to have the textbook. Okay, I urge you, I request the parents to get the textbooks for your children. Without the textbooks, they will not get the full benefit of my lecture. Okay, with that I want to move on to the subject. Since we covered this some time back, I want to refresh your memory by deriving or talking about areas of some plane figures. Now, the simplest one, of course, is a square. So, this is a square where all the sides are equal. So, I write it here. Sridhana's style is that we will write square here. And also, we draw a line like that, draw a line, not touching it. And then here we cross it out, we call it as side, S-I-D-E, yes, side, yes. Similarly, on this side, see how I am drawing, draw a line like this and cross it out here, and then here you write side, yes. You don't need to write like this, okay? That everything that you write here should be legible and you should be able to read it without turning yourself. Okay? Now, let us see the formula for a square. All this you know. Area of a square. Of a square. S-Q-U-A-R-E. Square is equal to side into side. So that is equal to S into S. That is equal to S square. We call it as square units. Square units. I got it? Square units. What it means is, if the side is in centimeters, then the area will be in square centimeters. Area will be in, we call it as square, put a period there, and then centimeters. You don't have to write yes, square centimeter. Suppose the side is in meters, then you say square, SQ square meters. If it is in millimeters, then you say SQ dot put a dot here, and then millimeters. Okay? So area of any figure, no matter whether it is a square, rectangle, side, rhombus, quadrilateral, any figure, any plane figure, area will be in square units. Because why? You may ask me, why it should be in square units? Because you are multiplying one dimension with another dimension. Here in this dimension you have whatever are the units, centimeters or millimeters or meters or kilometers or whatever. Same thing you have here, so it will be square centimeters. Now we move on to the next one. Okay? The next simple plane figure. We call it as plane figure because you can draw this on a plain paper or a plain board here. We are not talking about cuboid. Suppose if you take a book, the English grammar book here, this is not a plane figure. This is a three-dimensional figure. It has a length, it has width, and also height. So this is three-dimensional. But we are talking about plane figures means they have to have only two dimensions. Okay, all right? You got it? Now, let me talk about the next one. This is all this you know. This is a rectangle. So I write it as here, rectangle. Okay? All right? Now, here we have to draw a line like this, and then draw a line like this. This can be a little bit light. This is length, L-E-N-G-T-H, length L is equal to. Similarly here, this one, I draw it like that, okay, and then cross it out. This is, I don't write like this, but write like this, breadth, B-R-E-A-D-T-H, breadth B. Okay, that's how you represent the dimensions of a rectangle. Now, area of a rectangle, you know all this. Yes, area of a rectangle. You can use small letter or big letter, doesn't matter. Whichever you like. Area of a rectangle is equal to length L into breadth, B-R-E-A-D-T-H, breadth within brackets B. So sometimes you call it a LB or L into B. Again, this is also in square units. This is in square units. So length of a rectangle or area of a rectangle is equal to length into breadth, that is L into B, square units. So that's how you represent for a square. Next, after this, what do? Well, we will consider the next plane figure. The next plane figure is, we can go to a triangle, but I would like to go to a triangle later on, not right now. Then, let me see the parallelogram. Or why not go to the triangle? Also, I want to tell you, when you talk about the area of a triangle, I always tell my students, if you master the properties or the calculations related to a triangle, you almost mastered 75% or 80% of finding the area of plane figures. The only one that is left, probably, with considering your syllabus, the only one that is left is a circle. Of course, we have a hyperbola, a parabola, and an ellipse, and all the shapes are there. But in your syllabus, you have these plane figures plus circle. Okay. If you take a triangle, important. Now, just to follow the triangle, I always tell my students that if you master the triangle, you cover almost anything. Even for a square or a rectangle, you can convert a square into two equal triangles. Similarly, you can convert a rectangle into two equal triangles. So, first of all, you have to know how to manage, how to calculate the areas, perimeters and all that of triangle. Let us see here, you have a triangle here, this is A, B and C. A, B, C are the vertices. Now A, B, B, C, C, A, they are the sides. Now sometimes A, B, we also represent a letter small c, B, C is by small letter A, this is small b. How you do that? Suppose you take the side is in a triangle, you have how many letters? 3 letters are there. Suppose you have AC, you write AC, so AC, so B is left, so it should be small b. Similarly, BC, what is left? A is left, so small a. Okay. Or you can say the side opposite to the angle A is small a. The side opposite to the angle B is small b, like that, like that. Okay. Now, how do you find the area of a triangle? Area of a triangle is you use the formula area. Now here I forgot to write, again I have to write triangle. Okay? Triangle. So it implies, you see, triangle means 3 angles. Okay, alright. Now you write here area of a triangle. Triangle is equal to, the formula in general, it is equal to half into base into height. Base into height. Now here, suppose if I take this, let's say B here, and write C here. This is the base, BC is the base. Okay? So here I draw a line like that, line like that. I join these two. Okay? This you say, I call it as base. Base. Sometimes the base you can represent by B. So here is different, okay, but it's alright. Half base and then height. When you want to find, if you take BC as the base, the height should be the perpendicular distance between the letter A and BC. That means you have to drop a perpendicular here and measure that. This is 90 degrees. And if this height is H, this is equal to half into base, if we call it as B into H. Alright? Okay. For just to avoid confusion, I will call this as capital B. This is A, B, C. So opposite this is small b, base B. Okay? Opposite C is C. This is A. Got it? So area of a triangle is half into B into H. This again, of course, is in square units. Now you can use this, suppose you have a square. Square, if you join the two corners, then you are converting that into 2 right-angled triangles. Similarly, if you have a rectangle, if you join the two corners, then you are converting that into 2 rectangles. So this is how you can even calculate the area of a rectangle or a triangle using the area of a square or rectangle using the principle of triangle. Now, suppose you have, so now here I want to extend it a little bit more. Suppose I have a triangle like this. I call this is A, B and C. Okay? Now I want to take this as base. That means you have to try a perpendicular to this. So let us say I call this AC as the base. That means I have to try a perpendicular here. This is 90 degrees, this is 90 degrees. So I think you know how to draw a perpendicular from a point onto a line. So here, suppose you have a line, let's say AB, or let's see here, AC. I will call it as AC, and then there is B here. Okay, there is B here. Okay, how do I draw this perpendicular? So what you do is, with this as radius, you draw an arc. With this as radius, you draw another arc. You use these two to join it, and this is the perpendicular. Okay. So here, for example, if you want to find this height here, we want to find the height here. Okay, let us say AD. All you do is, if BA as radius, you draw an arc. If you CA as radius, you draw another arc. These two intersect, and that one, if you join, then that will be your altitude or the height. So, that means you should be able to, you should try to find the area of a triangle no matter what the base is. For example, I can draw a obtuse triangle, this one. Now I want to take this as base, but how do I draw the perpendicular from here? So in that case, I will extend it and draw the perpendicular. Okay? In that case, if this is a base and this is a height, then half base into height. Got it? So no matter what type of triangle it is, whether it is a scalene triangle, whether it is an equilateral triangle, or an isosceles triangle, you should be able to find the area of the triangle without any difficulty. Now we talk about a parallelogram. Now if you take a parallelogram is one where the opposite sides parallel, and they are also this one, these two are parallel. They are also equal. Okay, if h is the height, this is the height or the distance between the two parallel lines, and this is a base. This is a base. BASC base will be. So area of parallelogram, PA, RA, LL, E, LO, GR, AM is equal to B into H, the base into height. Okay, you can easily derive that, splitting the parallelogram into two triangles. That's the one. And then you have, suppose you have a trapezium or a trapezium. How to find the area of a Before I find the trapezium, I talk about the trapezium. I will talk about a rhombus. This is a rhombus. A rhombus is a plane figure where all the sides are equal and the diagonals intersect or meet at right angles. So this one is one diagonal. This is called DIA, GO, NAL. So diagonal D1, say. Now this is the one, and this is the other one. Say I draw a line like that. This is the diagonal DIA, GO, NAL, diagonal D2. And the area of the rhombus is equal to half of D1 into D2. Okay? Another formula, you can derive that. It is there in the textbook. Okay, you can easily do that. It should not be a problem. Now, let's move on to the trapezium. Trapezium is one where the two sides are parallel, the other two sides are not parallel. Okay. Now, let us say this is one side. This is one side. This is the other side. Okay. Let us say this is the distance between the two. So area of the shape, this side 1, this is side 2 into this is the height of the distance between the two parallel sides. So here I write it as trapezium, TRAPEZIUM, trapezium. Okay? So H is the height, or sometimes they call it as distance between the two parallel lines, height. That is H. So area of the trapezium again is equal to half of sum of the parallel sides, that is side 1 plus side 2 into H. Suppose side 1, if I call it as A, side 2 as called B, so this is equal to half of A plus B into H. So area of a trapezium is half of sum of the two parallel sides into the distance between them. You can easily derive this by drawing a line like that. This is a distance and you draw a perpendicular, you can do that, that's not a problem. Similarly for a quadrilateral also you apply the same principle. Now, today I don't want to muddy the things too much. So we learned how to find the areas of plane figures. I took the fundamental. Okay, so I reviewed, or I made you recollect the areas of some plane figures. Like first of all, square is side into side square unit, S square unit. Then we talked about rectangle, L into B square unit, and then we have a triangle of base into height. We have essentially a parallelogram that is equal to the base into height, any side. If you take any side and the corresponding height, and that is the area of a parallelogram. Then we also talked about how to find the area of a rhombus, that is equal to half of D1 and D2, where D1 and D2 are the two diagonals. In the case of a rhombus, all the sides are equal and the diagonals bisect at right angles. Okay. Now they also gave you the formula for the area of a trapezium also. Now suppose you have a quadrilateral. You want to find the dimension, the area of a quadrilateral. What you do is, in the case of a quadrilateral, suppose you join one diagonal, okay, this is A, let's say B, C and D. Now suppose if this height is H1, if this height is H2, okay. So if you take the triangle ABC, the area is equal to area of this. This is equal to half of AC into H1. Whereas this one, second one, if you take half of AC into H2. I didn't draw the line that well, okay, but here, let's say this is the one, okay, this is 90 degrees, okay. So area of this figure is half AC into H2, this one is half AC into H1. So total area is the area of the quadrilateral. So total area of the quadrilateral is equal to half into AC into H1 plus H2. So when you want to find the area of any quadrilateral, all you do is join the two, any two opposite ends or vertices, ends, and then draw perpendiculars here, and then so you cannot do it, then you have to extend it and find the perpendicular. And it simply is equal to half into the length of the diagonal into H1 plus H2. Okay, that's how you will find the area of a quadrilateral. I hope you understood how to find the areas. Now sometimes when you have a complicated shape, let us say a complicated shape like this, with proper dimension, how do you find the area of this complicated shape? So you know the formula for a square, a rectangle, a triangle, trapezium, like that, okay? So here what I will do is, I will draw a line like this. So this is 1, this is a triangle. Suppose if I draw a line like this, this is 2. This could be a rectangle, let's say. Suppose I draw a line like this is 3. This is a rectangle. I draw a line here, this is 4. So total area of the figure is equal to A1 plus A2 plus A3 plus A4. Got it? You see how simple it is? Even though it looks complicated, the figure seems to be complicated, you can break it down into number of known shapes. Known shapes. So what are the known shapes? You have a square, a rectangle, a triangle, trapezium. Actually, trapezium, we don't want to do that. We can actually do this. Suppose I will take it out. I don't want to do this here. This is like a trapezium. So this is one side, this is another side. These two are parallel, and you know the height. Suppose you know the height. Therefore, this side of this side plus this side into h. Suppose you don't remember the formula. You don't remember the formula. Then why do you worry about this? All this. You know the simple rule. You just draw a line. This is a triangle. This is a rectangle. This is a rectangle. That's a triangle. That's how you find the shape. You find the areas of some difficult or unusual shapes. Okay. Now let's see. Then let's move. I want to give you just a brief outline of the situation with the circles. How do you find the area of a circle? And then we'll do some problems in the next presentation. So here, this is your a circle. This is your center. We call this as center. C-E-N-T-E-R. Okay. Now the whole thing, the circumference C or perimeter is equal to, we call it as 2 pi r. Now here this is the radius, R-A-D-I-U-S, and you know this is the diameter, let's say A, B, center is O, this is C, OC is radius, OC is called, you know all this, I'm just trying to brush up your knowledge. OC is the radius and it is represented by R, and AB is the diameter, AB is the diameter, and you call it as capital D. Normally radius you should represent with a small letter R, and diameter with a capital letter D. Sometimes they may use even small d also. Okay. Now the circumference of this, circumference means it is start at one point and go all around and may come to the first point. How the distance you travel, that is 2 pi r. This is only linear units. This is a linear unit. Why linear unit? The only dimension is coming here is only one dimension r. There is no r square. So it is linear. Whereas area of circle is equal to pi r squared. So this will be in square units. Okay. Now this one is the total distance, whereas area means this whole thing. Okay, that whole thing. Here, this is the radius r. So area is equal to pi r squared. That is in square units. Suppose you have another situation. I will do some problems in the next class, next lecture, next presentation. It will be easy for you. Not a big deal. Suppose you have a ring. You have a ring. So this is, let us say, this is R, this is small r. Well, how do you find the area of this ring? So outer ring is pi capital R squared. Inner ring is, this one is pi small r squared. If you subtract, then you will get the area of the ring. So like that you have some problems. Now we have reviewed it. In the next class, I will tell you, I will take some problems. Let's say we will try to devote a little bit more time in the next class. Now, once again, I'm sorry, I covered this area of the plane figure some time back, and meanwhile we got busy with 9th class and 10th class Zoom meetings and video recordings and all that, so I was not able to get back to this very quickly, but hereafter we will be on the nose. We'll try to continue lesson after lesson. Okay? Thank you. If you like it, share it with somebody. And like I said, always, I want your comments. If you have a doubt, please do not hesitate to call me or send me a WhatsApp message. There are exercises at the end of the board and at the end of each section. So you have to start doing the problems. Maybe in the next class, I will take some problems and solve them for you so that you can do the rest of the problems on your own. Okay? Thank you, my dear friend. So, I'll meet you again maybe in a day or so. Okay? Thank you. Bye.